Alrighty, hello everybody and welcome to Physics for Today. In today's video, we're going to gain instructions for how to complete your very first lab in optics, which is images in a plane mirror. Starting to the production of this video, you should have received this green packet. This is your lab packet for this entire unit. Every single lab you are completing in this unit can be found in this lab packet, so it's important, please hold on to it every single day. To get you started, I'm going to talk about some expectations for your lab reports, and then we'll go into the instructions for your very first lab. So, some of the expectations that I have for you in your optics lab write-ups, the first most important thing that I want to say is that your ability to follow the directions and to be neat on these lab reports is part of your grade. So I'm expecting you to follow these rules as you move along, and we're going to do a lot of labs in this unit, as I said. So every single lab is on one lab per side of paper, and graph paper is usually your best option to complete these lab reports on. There's going to be a lot of drawings. It's very important that all of your drawings are completed with a straight edge, like the edge of a protractor or the edge of a ruler. This is because your light ray diagrams must be accurate. And the accuracy comes from you drawing light moving in a straight line, which is its natural physical tendency. It's also best that you use a sharp pencil to do this. This also helps your lines create more accuracy. You need to follow the instructions for each lab carefully. Every single lab will have a background, as you can kind of maybe see looking ahead on 1A, images in a plane mirror. You have your background section. If you forget any part of the explanation that's given to you, you have numbered 1 through whatever steps to walk you through what you need. There's images, pictures, and then towards the end of the lab, there will always be questions that you need to answer. It's important that you answer these questions in complete sentences, and those questions are answered directly below where you've completed your drawing. So you have an example up in the upper right-hand corner of your expectations here, where you're going to put your drawing and then questions below using, again, complete thoughts. For most labs, you're going to complete your own lab report unless I otherwise instruct you to do so. You'll always start by writing your name, date, and period in the upper right-hand corner, and then a nice neat label of the lab number as well as the lab title across the center, making it again very clear and easy for me to read. This is an example of a lab 1A report that I'm holding up in this image right here. Again, you have your center drawing. It takes up most of the page. My numbered questions answered in complete sentences on the bottom. And I have actually 2 pieces of paper for this lab because I completed 1A and 1B. Again, 1 lab per side of paper. When you're all done, you put them in subsequent order and staple them. This makes it so that I can move through giving you feedback through labs quickly, and also this is your most advanced level lab report for your final unit. So just a couple reminders as we're kind of moving through of drawing optical devices and light rays. We'll move through like this section and how to do it as we get a little bit closer to actually using the light boxes. For today, what's really important to note from this section is that light rays, the arrowheads that you draw them indicate the direction in which the light ray is moving. And then also, again, using a straight edge, a sharp pencil is going to be key in making your best optical devices drawings. Last step on the instruction page here is learning a new term in drawing today for constructing what is called a normal. You may remember in physics that a normal is the vocabulary word for perpendicular. It means in this context that there is a line that is drawn perpendicular to the surface at which the point, I kind of said that funny, a line that's perpendicular to the surface is what is called the normal. So your perpendicular surface is typically going to be a mirror. 90 degrees pointing out from that mirror is where the normal is. We're going to be measuring rays of incidence and rays of reflection, which you learned about in our introductory lecture. An angle of wherever the ray is always measured with respect to the normal. It is not measured with respect to the surface of the mirror. You also always draw the normal with a dashed line. You don't have to label the normal as the normal because the dashed line is what indicates that that is what the normal is. So let's kind of look at this image for constructing a normal to a flat surface. Your flat surface in this lab is your mirror. Your normal was drawn using a protractor that was placed along the flat surface, and then a point was marked at 90 degrees. A dashed line was then drawn from the mirror up to the 90-degree point. Then any angles measured, for example, like this angle of incidence coming into the mirror, is measured from where the ray light is to the normal. All angles being measured with respect to the normal in that sense. Great. So those are your expectations. You can always refer back to those at the front of your lab packet. For today, I'm going to give you the background and instructions for how to complete your Lab 1A, Images in a Plane Mirror. If you want to flip to that to page 2 in your green packet, know that these instructions are always there for you to follow along, and you'll have the opportunity to work through this lab and actually go through these steps here in a moment. So you're going to grab your graph piece of paper, you're going to label it with your name, you're going to title it, and then you're going to create an area where your image will be. This usually takes up about 2/3 of the page, so give yourself plenty of room to do so. When you get to your lab group, start by reading the background section and then walking yourself through step by step. Step number 1 is going to be drawing a line across the piece of paper, dividing it roughly in half. This is a line where your mirror is going to be. This is called line MM, and you're going to label that line as such by putting M on one side, and then M prime is going to be along the other side. I'm going to move my kind of camera over here so you can kind of start to see this lab setup and how it's going to look like as I talk about more materials. You have once you've drawn that line, you're going to have a mirror with a binder clip that helps the mirror stand up straight. You have your piece of paper, you have a piece of cardboard, and you have a sewing needle pin. All of these materials at the front of the room, and you're going to put them nice and neat back when you're all completed. So you have that straight line drawn across your piece of paper. It's line MM because it's the line where the mirror is going to sit, and you're going to do your best during this lab to keep the mirror standing on that line. So place the reflecting side towards you so you can see into it. And you have your metal stand, which helps it stand up. About 5 centimeters in front of where the mirror is, you're going to place a dot, and you're going to call that point P. That is where you're going to ultimately be placing the pin, which is the object for this plane mirror lab. In order to actually put the pin on point P, you're going to slide a piece of cardboard underneath your piece of paper and then put the pin into point P so that the pin stands vertically up at this point, and the image of the pin can be seen in the mirror. This is where you actually start to get to look at rays of reflection using your eyes. So you have your straight ruler protractor handy. To find the direction in which light is reflected into your eye, you actually have to get eye level with the image of the pin. A reminder that this physical pin is the object. The pin that you see in the mirror is the image. You're going to get eye level with the pin until you can clearly see the pin the reflection of it coming into your eye. You're going to use your protractor as a tool. Lay your straight edge ruler on the paper about 5 centimeters to the left of the pin. Make sure your mirror stays on the MM line. Now this is where you get low. You look at this from the line of where the protractor is. Keep one eye open and one eye shut and sight along the edge of this ruler. You're going to be moving it back and forth, slowly changing the angle until the line of the ruler directly points at the image of the pin that is in the mirror. Do not point it at this pin directly. Point it at where the image is. When this edge is lined up, keeping your mirror on the MM line, you're going to draw a straight line along the edge of the ruler. No big deal if it doesn't go to the mirror at first. You can always add that on later. So there's the image that you see. There is the reflected ray that you are drawing from your eyeball across the straight edge of the ruler. You're then going to repeat this step, but now you're going to move your ruler about 5 centimeters to the right of the pin. Do the same thing. Look for the reflection of the pin using your eyeball, lining the ruler straight up with the image that you see. And once you have it, draw a reflected ray from where your straight edge of your ruler is, which shows the ray of light that's going from the image of the pin to your eye. Do this one more time, maybe now going about 5 centimeters to the left of the very first line that you drew. You might need to shift the mirror over towards the left so that you can actually see the reflection of the pin. You're more than welcome to do so as long as it stays running along the line MM that you created. So there you go, you see your reflected line that is drawn there. And now you get to remove all of your devices. You just need your piece of paper. So you have your paper here. You're going to extend each sight line behind the mirror. So now we're talking about the angles of light that we're seeing within the image. You're going to draw the lines straight and flat till they reach the edge of where the mirror is. And as you extend them backwards, they become dotted lines. Dotted indicates that we're in the virtual world. Where your 3 lines intersect, and you know you've done this correctly because they will all intersect at the same point. If they don't, select a middle point that's in the area bounded by the dashed 3 lines, but it shouldn't be that big of an area. This is going to be labeled P prime, which is the position of the pin's image. Then you're going to connect the points from P to P prime. Label the point where the line intersects the mirror as point H, right there. Now we're going to just do a couple line drawings. We're really going to find where is our rays of incidence on our already constructed reflected rays that we have here on our image. So draw from point P, where the pin was in your paper, to the mirror where one of your sight lines hits the mirror. Repeat this for the other 2 sight lines. So there's the first one from P to the sight line. There's the second one from P to the sight line. There's the third from P to the sight line. You're going to then indicate, you don't have to write it on there, but if it helps you, you can, which is the ray of incident and which is the reflected ray. A reminder, the incident rays come from the from the object into the mirror, and reflected rays go out from the mirror out to where your eyeball was. So the direction of the arrow indicates whether or not it was incident or reflected. Now you're going to draw normal. Remember, this is the new vocabulary term, a dashed line for each pair of rays. So this is your dashed line normal for the first pair, the second pair, the third pair. This normal helps us indicate where is the angle of incidence and the angle of reflection. The angles go from the ray to the normal. So this would be the angle of incidence and this would be the angle of reflection. You're going to measure each angle using your protractor. Now you have another measurement, and then you have your third measurement. You should have 3 normals and 6 measurements, 3 of the angle of incidence and 3 of the angle of reflection. This is kind of like the final, just full label of what everything should look like for something like this. Also kind of put my complete lab report up here that shows you your different incident ray, reflected ray, the angle of incidence, the angle of reflection, and the normal. Once you have your full complete drawing, you're going to answer the questions at the bottom of your page in complete thoughts and complete sentences. I do not expect you to fully complete this lab today in class, but I do expect you to use your wits and your ability to read instructions and problem solve to get yourself started. I will be available for questions later this week. I hope you have a good time with your mirrors today. Good luck, and I'll see you soon.